assume that means we're probably supposed to start. So my name's Wade Schulz. I'm an MD PhD candidate at the University of Minnesota, as well as chief scientist for Agile Medicine, a company that we do for healthcare information technology and healthcare data management. I'll let Brent introduce himself quick here, too.
Brent Nelson. I'm actually a medical doctor and psychiatrist, but I've been building commercial software since the mid-'90s. Prior to medical school, worked in financial services industry building distributed internet systems. So did the medical thing, and now back into health informatics and trying to deal with some of the issues we have in healthcare. So we're going to talk a little bit about that today.
Yeah, so really what we want to do is address a little bit of the problem space in healthcare IT. So what are the issues with the current health IT infrastructure, and what are some of the solutions that we can do to try to improve that moving forward? And just to kind of provide some perspective, and if I'm talking too fast, let me know. I've been through the better part of a decade of education, so I don't really like being in lecture. So I'll try to get you out of lecture as quickly as possible. So for tech and mobile advancements, we've seen a huge explosion in things like mobile technology for end users and in the financial services industry. We haven't really seen that in healthcare, and there's a wide variety of reasons why there's been some slowness to adoption there. But just kind of think, if you weren't able to access any of your information from home, so you couldn't get to an Excel file or you couldn't see your email, you wouldn't be able to get any of that on your phone or mobile device. And just going a little bit further, imagine if you weren't able to send money from one bank to another by anything other than check or cash. And in medicine, this is where we really start to see the breakdown in the current health IT infrastructure. You can't send a patient chart from one hospital to another without printing it off and faxing it, or printing it off and giving it to the patient to walk to the other location, which is really problematic. Also, one thing, think if your workstations were still running Windows 95. This is unfortunately the case in a lot of clinics and hospitals. They can't upgrade. They've got stacks of computers from people that recycle them, because if they move to Windows 98 or anything even newer than that, their software will no longer function and they'll lose access to all of their past medical records. And then the other one, which is also really hard to imagine, is think if you, every morning when you came into the office, rather than just being able to pull up a chart on your computer, you had to instead copy it down by hand and then type it back into an email because you couldn't copy and paste it or couldn't open that file in a different application. And these are all very common. And I don't know, Brent, if you maybe want to talk a little bit about, your normal day when you come in. What's your first couple hours spent doing as a physician?
Yeah, it's really tricky. I mean, you come in and let's say you have 16 patients. You got to round on them. You basically got to get up to speed on what happened to them overnight. You want to know what medications they're taking. Did anything acute happen? Do you need to make any changes? Do they have any new lab results? So instead of you walking in and somebody handing you a tablet or you firing up your tablet and just seeing all of that, you literally sit down at a workstation that's probably Citrix powered if you're lucky, and you start looking things up manually. People are writing things down on paper, and you spend the better part of an hour, hour and a half literally copying data over. It's ridiculous. All with the double rub of the system you're using likely costs around $100 to $200 million if it's been rolled out recently. It's pretty perplexing.
So there has been a slight explosion in healthcare IT, especially centered around mobile devices. But most of this has been in the end user or consumer base. So the healthcare consumer, patients, people with either healthy or chronic disease. So we were at CES earlier this year, and the big explosion in the healthcare section of CES were all of the portable devices for looking at pulse or sleep patterns. And for the consumer, as physicians, we definitely want to drive consumer-driven medicine. So we want them to be participants in their healthcare. Unfortunately, most of these applications are a little difficult to use, and they don't provide all that much useful data once you actually go to see your clinician. So they're interesting, they're kind of fun, they can get us some useful information, but really in long-term health, they aren't super useful. The other thing that we've seen is the explosion of personal medical records, things like Health Vault and then the recently canceled Google Health, where people can look at their own health data, and this is just a picture of one of the Health Vault interfaces. And again, this provides some useful data, but it's, again, pretty limited. So you can see your heart rate. If you have diabetes, you can see your blood glucose. But outside of a set of a couple diseases, asthma, diabetes, hypertension, they don't really give you much information about disease management or healthcare management. And there hasn't been a great adoption of hospitals into these systems. And then the thing that's used most commonly is actually the EMR system. And this is actually an EMR system, one of the most widely used. It's used by the Veterans Administration. It's called Vista. And a good portion of it is still command line. They do have an interface. And a couple of the larger software vendors actually use this same system. This was built by the US government, so you can actually go and download the code yourself. And a lot of the healthcare EMR vendors just go download this, build a new interface around it, but they're still locked into this older technology.
And I think to put one thing in perspective, patients being managed, the costs associated with that, in average inpatient stay, you're looking at somewhere between $2,000 to $3,000 a day. If they're in the intensive care unit, you're looking at more like $15,000 a day that people are paying to be helped. And these are the kind of tools we're using. This is the state of the art as far as the government's concerned.
So what are some problems with these current systems? We've already talked about this a little bit, and I'm sorry this is a little small, but I had to save some room for the fantastic code snippet everybody is about to see. So a lot of these, the one that I just showed you is built on a language called MUMPS. And that was made by Mass General Hospital back in the late 1960s, prior to C and C++ being around. And that's what is used to, or was used to write Vista, the VA's healthcare system, as well as Epic, the EMR out of the company from Wisconsin. And just to give you a little bit of idea, Vista had its last major update in 1992 and is still used in every VA hospital across the country. This is just a little bit of text out of the Wikipedia entry, and I just want to kind of call into this last sentence here. It's generally recognized that this code is not very readable to many programmers today, though it should be noted that the code is expert-friendly, i.e. to acculturated Vista programmers. It is readable and appropriately structured. And this is just a code snippet. If you go to Wikipedia and Google mumps, go to disambiguation. You want the programming language, not the disease. But this goes for pages, and all this code does is actually for managing date and time. This is the first part of about 3 pages worth of code. And the way that they make that sound better is that in any other language that could be more readable, this would take up much more memory because you couldn't abbreviate everything. Every keyword can be abbreviated to a single letter in mumps, so that means there's only 26 keywords in the entire language. So Q is quit, W is right, and some other ones that I won't even begin to explain what percent equals percent means. It's just not even funny. So, and then I'll let Brent just kind of run through a couple of the other issues that we experience with current EMR systems.
Yeah, so as the rest of the world moves forward, medicine stays put, and it's really, these are a few of the many problems we see. Scalability is a huge issue. People try and just throw more hardware at it rather than thinking smarter about how the system should be designed, and they stick with client server, Citrix, interfaces, running it all on the server, throw the client away, as thin as client as possible, don't trust anybody. They can't handle any types of data, so all of the databases are designed with very specific metadata in them, so there are no basic semantic markups in the database. So you get a column, it has some random name. In some of the EHRs, the column name is actually a GUID. So you have no idea what the data are and how the relationships work when you go from vendor to vendor. The security implementation is really, if you have a username and password, you can get into any patient across the entire VA system or across the entire health system. So these really big health systems that have millions of patients, if you can log in, you can do whatever you want, generally. You can't order prescriptions or lab tests, but if you have a doc's signature code, then that works too. Poor standardization. The interop, people are saying they're talking about interop with XML standards and various consortiums and that sort of thing, but it really doesn't happen. In practice, you see big health systems generating really custom concrete schemas to try and exchange data. They spend years and many millions of dollars, and it never works. And then asking for reports. There was a new black box warning on one of the medications we use, and we asked to query our patients to see who was on the medication, and they said, we don't know how to do that. Seriously. I mean, this is a big deal. And this is not a small vendor either, so it's a huge problem.
And one issue with a lot of the newer software applications that are coming out is they try to make this seem like not a big deal because really, what's the standard encounter? You have a patient that comes in, they've got some problem, otherwise they're relatively healthy. They see the nurse, they get some vitals taken, they go talk with the doctor for a little bit, and then they see a rather intimidating looking pharmacist, I apologize for that, and get some medication, go home, they get all better. So from the standard encounter, let's just assume that, let's pretend you're the doctor, the PA or NP. It's a 48-year-old male patient who's pretty healthy. He's just in for his yearly physical. He's got hypertension or high blood pressure and hyperlipidemia or high cholesterol. He's got some family history of heart disease and a mother with breast cancer. Smokes 1 pack per day, drinks a little bit. Vitals are relatively normal other than a little bit elevated blood pressure. Physical exam is normal, and you get some labs to look at his cholesterol, which are a little high. So the doctor starts him on a atorvastatin and a blood pressure med, and he's counseled on a smoking cessation. So from this, again, standard encounter, the things that we have to digitize are basically the patient's demographics, the consent and privacy forms that they sign and fill out initially, his vitals and labs, which for this patient are, a couple of numbers. The doctor enters his note, the 2 medications, and then they're going to report to the state that they counseled on smoking and things like that. So this makes it seem like managing healthcare data isn't really a big deal. Unfortunately, this is only a subset of our patients, and most of them come in that are a little bit more complicated. So let's assume a different encounter. We'll call this what actually happens in, this isn't every patient. They won't be all this bad. But let's say you have somebody who comes in as a 73-year-old male patient. He's not feeling great and has some low energy. He hasn't been able to do his regular activities, so he's got a little bit of depression now. His past medical history, he's got diabetes, hypertension, and hyperlipidemia. He's also been smoking about 2 packs a day for the last 20 years, so he's got COPD, chronic or congestive heart failure. He also had a heart attack about 5 years ago. He was diagnosed with prostate cancer about 1 year ago. They decided not to operate on it because it wasn't very advanced. They take some vitals. He's got elevated blood pressure and an elevated temperature. And because of his past medical history, they look at an A1C, which is for diabetes, and that's elevated. They also grab a PSA, which is looking at the prostate cancer, which is a little high, but similar to what it was about a year ago. Because he's got a temp, they do a complete blood count to look for infection, and they find out that his white blood cell count is extremely elevated, and his hemoglobin is extremely low, so he's very anemic. His primary care doc doesn't exactly know what's going on, so they refer him to a different facility. The doctor there refers him for a hematology oncology consult who orders a bone biopsy. They grab an EKG, which looks fairly normal, a chest x-ray to look for pneumonia, which was clear. They do the bone biopsy and have pathology read it. And they also grab a bone scan to make sure he doesn't have any metastasis of the prostate cancer. He's unfortunately diagnosed with AML, but there is a research study that they enroll him in. They decide to get some next-generation sequencing data as well as flow cytometry from his blood. And from this, they generate about 100 megabytes of clinical data, not that much, and about 10 gigabytes of processed research data, which actually started off as about 2 terabytes of information. So this gets a little bit more difficult to look at. How do we actually store each of these pieces of information?
And one other thing to mention, this guy's sick. He's really sick. He's a white cell count of 50,000 is not good. This guy could die really fast. And so you have all these folks who care about the patient, and they're really working hard to collect as much data as they can and to bring the latest science to bear on his problem and figure out, okay, how can we give him the best life expectancy possible? But in the process, you have to wade through this massive quantity of information that comes from so many different sources and is in a whole bunch of different systems that you have to access.
Yeah, and so when we look at a few of the things, what differentiated our first patient and our second patient in terms of data, and that comes into each of these different things, EKG, imaging, pathology, sequencing, and flow cytometry. Current EMR systems don't handle any of this. None of this gets stored in the EMR. The EKG, after it gets printed off, gets scanned in and added into the EMR as a picture about 5 hours later. Your imaging is a completely different system that doesn't have any single sign-on and no interaction really with the EMR other than getting the patient's birthday. Pathology, so that blood smear, while those get scanned in and digitized, only the pathologists see that. The only thing that gets added into the EMR is a written report of what the pathologist saw, so your other physicians can't see that. Sequencing, next-generation sequencing is fairly new. It can basically sequence somebody's entire genome in about a day. It costs about $1,000 now, so they've really brought that down. But when you generate all of that data, there is nobody that really knows what to do with that yet as far as managing it or making it useful. And then looking at the consult information, he saw his family practice doc in his hometown, went to something like an academic medical center, and the internal med doc sent him to a hematologist. None of that data can really get passed around, so you're stuck with either trying to get paper charts moved around or fax that information from one provider to another.
So back to our problems, we talked about, we'll talk about scalability a little bit more, but the multiple types of data is really the problem, because who is the burden of managing the data? Who does that fall to? Does it fall to the doctor? Does it fall to the clinic? Does it fall to the health system? To the IT folks? You have this intersection of this really massively complicated data set with really the need for novel computing techniques and database technologies and reporting systems and interoperability and just mobile, like everything you can think to make things more efficient, because the cost of healthcare are skyrocketing, the people available are decreasing, and we have 88 million baby boomers coming that are going to retire. So what do? Really, ultimately, you need systems that are capable of scaling. You need systems that allow people to get the tools in their hands that can make decisions but not know anything about the technology. A lot of the revolution we're seeing in the mobile space. People are doing really sophisticated things with their phones, with their tablets, with all of the technology, but they don't need to know anything about it. I always call it the grandma phenomenon. If I can hand a piece of technology to my grandma and have her tap through, well, that says something. If she can get the job done. Really, doctors are the same way. They're not tech savvy. You need to be able to just put something in their hands, and they need to get the information they need without knowing how they're getting it.
So at this point, we're going to start going into a couple of different demos just to demonstrate, how can we potentially solve some of these problems. Before we get in there, did anybody have any questions at all on some of the first stuff?
Yes.
Yes. There's multiple owners as well as different levels of privacy, and we'll get into that a little bit more once we get to the security implementation using some claims-based authentication. But yeah, each hospital is kind of a data owner, and without the proper release, one hospital can't just send that to another one without getting consent from a patient first. Yeah, so Google Health is similar to Microsoft Health Vault. It shut down, officially I think about 6-8 months ago, and is on its phase out yet now. One problem for them was they don't have a lot of healthcare people at Google. So how do you make that, and how do you make that useful for the consumer? So when I popped up that one image of Microsoft Health Vault where you can see your pulse and blood glucose, okay, that's great, but it didn't really handle much data other than that. So how do you get adoption? How do you make that useful to the consumer? You can see your pulse, but is that really providing you any benefit, either short or long term, other than it's maybe kind of cool for the first 2 or 3 weeks you play with it? So they've tried, but the personal health record arena is where they were working, and that just hasn't really caught on with a lot of consumers yet.
And they kind of proved the point of that the last 12 years of web service revolution has proven that data silos aren't acceptable anymore. There needs to be a way to have composable systems. So a big single cloud is not going to cut the mustard for the health system, especially the CMIOs of these big health systems that have 1 million patients and $10 billion of liability. They're not going to ship everything to Google.
Oh, yeah. Yeah, so there are a lot of different use cases. You've got your physician in a clinic versus physician in a hospital versus nurse in either of those places versus long-term care or acute care. What we're going to demo is more on the back end. How can we improve these systems? And then, using whatever technology, whether that's mobile or desktop or web-based, make those interfaces to revolve around it. One thing that's really important with this is again, that multiple types of data. So sequencing data. Up until 2 years ago, you could sequence small pieces of the genome. Not a big deal. We just say, is this a positive or negative result for a screen? Now that we can sequence an entire genome, you can't store that in the EMR. So what happens in 5 years when we get the next new technology? You could hard code the EMR to accept some of that, but right now there's no dynamic way to add new healthcare data, and the body of medicine, what do they say, doubles every 5 years or so. Yeah. So how do we make these systems really forward-thinking and allow to do that without completely restructuring the architecture and charging the hospital another $200 million for an installation?
And also, how do we take advantage of what's been learned in other industries? I mean, I came out of the financial services industry, and they've been working on this for 25 years, and have learned a lot of really important lessons. I mean, again, back to the original thing, you wouldn't expect that you couldn't transfer money from one bank to another. That would be unacceptable. So how is health information any different? And the knee-jerk response from a lot of the health vendors are, well, you don't understand. This is so secure, and this is such sensitive data. It's like, really? More than money? I mean, So it's just a matter of getting people to make the brain shift.
Absolutely. That is part of it. I mean, a lot of the certifications that you need to create a new EMR are fairly expensive, and it's really an unfamiliar area for a lot of people. So since it's so specialized, nobody else has an option, so they can charge. If you're stuck with my EMR, it's impossible to transfer to another system. Exactly. In 10 years, you have to come back and buy it again because otherwise you lose all of your data.
Yeah.
Yep. So you mean like a different lab test or something like that? So
not often.
it depends on, so I mean, generally the issue that we have right now with hospital systems is having too many patients and we can't get enough of them through the care. So, you know, without buying 3 more MRI machines, they probably wouldn't be able to get a lot more use out of them. So there is a lot of work that's going into the research of, you know, well, even if the doc had that other MRI, would they still order a new one anyway? And that gets into a larger discussion of healthcare cost and everything else.
And there's a huge pushback for reimbursements. I mean, that's the other piece of this puzzle is it's not really the patients that are paying directly for the services. It's an insurance company or a healthcare plan or whatever it may be. So sometimes they'll just say, well, if you run something twice, they just don't pay for it. Or if you do something wrong, now it's getting to the point where they won't pay for a hospital stay. At $3,000 a day times 30 days, you know, you're talking about $100,000 that the hospital's just out. So to them, there's a real incentive to get their systems better and to understand not only the financial impact of the decisions that all of their folks are making, but also the health impact, because ultimately everybody's kind of hemorrhaging money and nobody knows really why.
So we'll get into a couple of demos here real quick and we'll grab some more questions later. So the first thing that we're going to do is load part of a genome. I would load the entire thing. I can do that in Mongo very quickly. Unfortunately, SQL Server can't quite keep up with it. So just a little bit of basic genetics so you guys know what I'm loading is the human genome has about 46 chromosomes, and those are paired chromosomes. So 22 of them are paired, and then the last one is an XX or an XY, depending on if you're male or female. Those 46 chromosomes have about 3.2 billion base pairs, and each base pair is basically a 2-letter combination of adenine, cytosine, guanine, or thymine, so A, C, G, or T. There's a bunch of different ways that we can sequence genomes. The big one that's very popular right now is next-generation sequencing. If you want, go Google it. You can find large technical discussions about what it is and how it works. But basically, you can sequence an entire human genome in less than 24 hours for really about $1,000 at this point, and the instruments can fit on a table about this size. Life Sciences just released a new one back in January. And so this generates a lot of data. It can be very useful, but is mostly used in research right now. It's not really used very clinically. The thing that is used clinically more frequently are single nucleotide polymorphisms. And what those are single nucleotide changes that give us the variation between one individual and another. So most of the human genome is similar. That's what makes us different from every other animal. It's these SNPs or SNPs that give us the difference in hair color, eye color, or everything else. And there are a bunch of companies out there that can actually do this Sniff Analysis, one called 23andMe, 23andme.com, which for about $200 can actually, they'll send you a little swab, you swab your cheek, send it back, and they give you your entire Sniff analysis. Manu Sporny, he's the founder of Digital Bazaar, has actually open sourced his genome. So you can go to github.com/msporny/DNA, and you can actually download his entire SNP analysis. He's put it up there for everyone to look at. So this is actually what we're going to be loading up here real quick, just demonstrating the difference of loading into MongoDB versus SQL. So again, this is a large amount of data. Sequencing stuff is very new compared to the typical lab tests. And the advantages of something like a document database are that we can dynamically enter data, dynamically query it, and we can enter it much faster. So I'm just going to be using one instance of, let me see if I can get my screens to duplicate here real quick so I can actually see what I'm doing. I'm going to be using Entity Framework to load this into SQL, so I know there's obviously optimizations you could make to try to make this faster and improve this. But just to show a very base level of if you want to do a quick implementation and load this data, how long does it take to get into SQL Server using Entity Framework versus getting into Mongo with the 10gen driver. And I'm not sure how many of you are familiar with .NET. That's what we're going to just go through for all of these demos here. But both Entity Framework and the Mongo libraries can be added through NuGet. You can just go and find those packages and add them in. And we're just going to load these both up onto my development machine using the same class. So the same structure is going to happen for loading and everything. So this is, the Sniff Analysis is basically a 23 megabyte text file. Each line has an RSID, which is the genome, or that SNP ID number, the chromosome number it was found on, its nucleotide position on that chromosome, and then the 2-letter genotype. So let's go through and load this real quick. We'll see if it crashes on me or not. Sometimes it gets a little bit cranky doing all of this on my laptop at once. But so there, MongoDB loaded in 1,000 of these snips. There's about 988,000 total in 0.15 seconds. So we loaded about almost 6,400 snips per second. SQL Server is really running. It's trying to get these in too. There we go. Finally got done. So those same 1,000 snips, it loaded in about 13.3 seconds, 75 snips per second. So again, there are optimizations you could do to make this go much faster, but just the default out of the box gives us, moving into those document databases is far superior to using the SQL Server for managing this type of data.
And part of the kind of the who cares phenomenon is, how do we explore new technologies and bring it into an area that hasn't been doing that at all, and so document databases are a really good example. I mean, could we use BCP with SQL Server and load it all that way? Sure. But with MongoDB, we were able to just craft a tiny little class, put a couple of attributes on it, and zing, we're off to the races to try a new way of looking at data. So it's really kind of about the agility and the simplicity, and hopefully in the end, the fewer bugs too, because we're writing less code more quickly and iterating faster.
And so for those of you who aren't familiar with MongoDB, basically it's just storing it in a document JSON formatted, and this is what that structure looks like after we stored it in. So I gave them all an ID here, just like I did in SQL Server, loaded in the data, just much faster than what we were able to with SQL. So next thing we're going to talk about are a couple of things. We're going to pair together the security implementation and then the standardization. I'll let Brent talk a little bit about those two here real quick.
Yeah, so security implementation is something that's very important, but that often does not get addressed. People love the hard candy shell and soft sweet center approach to a lot of security, where it's like, you protect the borders, you don't let anybody in, and you're like, oh, we're secure. And I say, what's the most secure computer is one that's not plugged in or running buried under a mountain, right? But that's not obviously the way we can do things anymore. But that's the way people are still doing things in healthcare. So we need to look at other innovations that have been made. And so one thing we like is federated security, the idea that people can make claims about who they are and then have those claims validated by a wide variety of trusted authorities. So those claims can be passed around. They follow providers. When providers move from health system to health system, the claims can follow them. Patients have claims, so patients can log into their data. Everything's secure. And it doesn't assume any specific technology stack, too, because, you can't tell another business what technology they're going to run. You have to be able to work independently. So we have a couple of interesting toolkits we're using to kind of demo that.
Yep. And did you want to go standardization stuff real quick, too?
Oh, yeah, sure. Yeah, so poor standardization. So standardization is another problem. As I was saying before, the databases and a lot of the systems we interact with are just very old school or rigid, where it's all just opaque data formats. You have no idea what the schemas look like, much less are the schemas actually described and published anywhere where they can be programmed against by third parties that are otherwise not affiliated with the vendor that someone's using, which is really important. And so what happens is over time, if you have these systems for 15 years, you have this creeping cruft of cobwebs that build where, there's like lore around how the system actually works and what certain data types mean, and no one really knows because documentation has never happened. And so, part of it is saying, all right, what can we save in pain and suffering for ourselves by using data standards that are self-describing, published, using technology agnostic formats. So that's something we've been looking at. And then also leaning on more than just syntax, because syntax is important, but also semantics. What are the semantics of the data that we're storing? Because that's actually the most important part in many areas, especially healthcare, because you got to know what it means. If you can look at it, well, that's fine. But if you don't know what it means, who cares? And so there are some really interesting things that have been done around both format and about semantics in healthcare. One are these health ontologies, and we'll talk a little bit about that. Out of Mayo, actually, of all places, they've been working on something called the UMLS, which is this giant 8 million row record set where they go and they try to just describe every term they could think of in medicine. And they put it all into a giant database, and they put it onto what they call the Lex Wiki, where people can, from a community perspective, edit and update and add, and it's cross-reference, and it's actually really a neat system. And it takes into account all these different codes that billing providers use, that pharmacies use, that lab companies use, and it's all fully cross-referenced and actually uses formats that are compatible with triple stores or document databases. I mean, really, it's a neat data set. But it just nobody's actually done that with it. So the data is like sitting there waiting for someone to take it and slice it and dice it and reconstitute it. So that's the ontology part. Then there's also a few specifications out there in data formats, and you can Google these: CCR, CCD, HL7. These are like the web med standards, and they're really, really ugly, beautiful, great, horrible. I don't know. Depends on your perspective, but they're really unwieldy. I mean, we've worked with it. We built about a 1 million patient data system where we loaded a whole bunch of CCR, CCD data in it, and these formats, they're really abstract. There's holes all over them. They're like leaky semantics. They're just kind of gunky to work with. Nobody ever put the stake in the ground and said, this is what this particular element means. They're like, well, this element's polymorphic and it can change. It's like, you have no idea what you're coding against. So they're out there, but people don't really use them. They're like, oh, we'll export these things because it's easy to export stuff, but no one will accept it because they're like, well, I don't know how to parse it because you could send me just about anything in them because they'll describe, they could describe skyscrapers. I mean, they're insane.
Yeah. So just to give a little bit more example on the ontology side of this, so like Brent said, a lot of these databases code these with strings or maybe nothing. So why can't we just go through and search and say, well, if it says hypertension, which is high blood pressure, why can't we just do a string search? Well, one of the problems is using this UMLS system, if you search for hypertension, it actually gives you 858 separate results. The top 3 matches are hypertensive disease, which might be what we're really looking for. The other ones are hypertension adverse event, and then the next one is no hypertension, which is completely opposite to what you might be looking for.
And as your doctor, I did one of 3 things. I either maybe treated you appropriately, I missed something and you died, or we're just ignoring you altogether. I mean, it's a big deal,
Yeah, so a slight incorrect string match could be somewhat problematic. And then even once we narrow down, so let's say we go with hypertensive disease, each of these coding systems has a further breakout. So ICD-9 and ICD-10 are 2 of the big billing systems, and then SNOMED-CT is one of the international coding systems. And ICD-9 actually splits hypertensive disease out into malignant, benign, and unspecified for billing purposes, but this is what's sometimes being internally coded, which can make it really problematic. So what we're going to look at for this demo is using kind of a similar data set, except we're going to just use some pulses, blood pressures, things like that. Looking at how can we do single sign-in using Windows Identity Foundation, or WIF, which is Microsoft's Federated Identity and Security solution, to kind of fine-tune our security options for the data set, and then using the UMLS concepts rather than any specific coding system, so that if you use these concepts, you can go into that lexical terminology, go through and expand out to every code system that you want afterwards. And this just makes it a common and really technology agnostic solution for formatting and grabbing this data. So if we pull up what we're going to load here, basically the class is very similar that I'm going to be using for loading the data, except we're going to give all of our patients a URI. And what I actually did here was split up our patient data into SQL Server because all of that's very relational. It also allows us to do, live encryption straight in the database and everything else. So, there's some things that the relational databases are still really good at and should be used for, but then splitting all the patient data out into the document database. The CUI is the concept unique identifier, so that's going to identify what our term is, and then the lexical term is the suggested string for that. We're going to add in a couple of claims for each of our pieces of patient data, and that says who has access to this piece of data as a user, and then the actual entry which contains the data for it. So if we look at our loader really quickly, we're going to give James Kirk here a little bit of a health history. We're going to have 2 different claims, one that says that a physician can read the information, and then one that the insurance company can. And what we're going to load in then is each of these concepts. So I've just got a couple of random data generators that are going to load in about 20 different pulses, 20 different temperatures, as well as, since he was out on the town a little bit, he needs to go in for an HIV screen and some follow-up testing afterwards. And this is really where we get into the security issues. If your employer can see your medical record or your health insurance company, you may not want them to see that you had to go in for an HIV screen. However, if you go back in for confirmatory testing and it's negative, you may no longer care. So really being able to fine-tune those results rather than just a bulk, you have access or you don't, which is what you currently see. So I'm just going to run this to load the data real quick. And again, for anybody who's interested in doing something like this in .NET, you can actually set up a WIF solution in about 30 seconds. So if you go to the NuGet manager again and add in the WIF packages, it'll actually give you this add STS reference, which is your security token service. And it will generate your dummy token service. And this is all in the security framework. So the token service is what issues your claims and tells you what you're allowed to see. And if we look at that, this is by no means best practices for coding a token service. But what we're going to look at is just say, if you are the physician, you get a claim of physician. So we're just doing this by username. If you're anybody else, so your username isn't in that physician list, you're going to be assigned the insurance claim. So when you log in, the STS assigns those claims to your account, and then that's what says what you can actually see for the data.
And the nice thing is the Patterns and Practices group at Microsoft put out a document that kind of talks about the different ways you can set up STSs and that you can federate your claims and sort of the different use cases for more common scenarios. So it helps kind of walk through, because it gets a little
messy,
confusing. Yeah.
And Windows Azure actually has a full STS that you can sign up with too, and use Google Auth or several other authentication mechanisms. It has those all built in. So what we're going to first log in with is Starfleet Command. They luckily have great employer-provided health insurance. So we're going to log in and look at what we actually generally see in the patient's medical record, which is unfortunately just this tabular data of every result that you've basically ever had. Fortunately or unfortunately, depending on how you look at it, you wouldn't actually see all these vitals in a normal EMR because that's on a separate tab than what all of your labs are, because labs are less frequent. They separate them out a little bit because there isn't really any mechanism to filter.
And they're often separate systems too, because the lab will be providing data in one system, nursing is going to be using another to grab your vitals, and there are usually, lots of paging involved. And this is the part where you come in the morning, you want to see a patient, you go here and you zing through the list and you look for their high, their low, all of the trends, and sometimes you make your own little chart. It's insane.
So just to demonstrate the claim, this is actually an authenticated, but the claims are not applied to this page. So you can see when I scroll down the result of the HIV screen, which showed up positive, and then later the confirmatory test, which is negative. So this is just showing every result. If we now go in and filter based off the claims that were actually assigned, we can scroll back down, and this is difficult to read, but we'll fix that in our next visualization demo. You can now see that the confirmatory test is still there for the insurance company, but we've lost that HIV screen. So again, really fine-tuning those permissions on a per test or per result basis gives you a lot more flexibility than what the current systems can really accomplish.
Yeah, so back to my last point too, is the difficulty in generating reports. Many of the systems that have evolved in healthcare have been about abiding by standards, national standards of healthcare. So one thing's called JCAHO. There's kind of these oversight bodies that watch hospitals and doctors to make sure they're doing the right things, not to really provide decision support. So it's not about really giving the provider a better sense for what's happening with the patient. The provider still, it's just assumed that your training will cause you to do that. Well, we know that's not always the case. So really there's, I think, a nice move that's happening slowly towards really better data visualization in some of these systems. So doing a lot of graphing, less tabular, or if there is tabular, making it with the graphing, but being able to filter. Next one. So there's a guy that we love called Tufte. He's out of Yale. I don't know if probably a lot of folks are familiar with him. He has these phenomenal talks. He comes in where he brings these old books, and he talks about how do you really provide information that's high resolution in nature in a way that communicates as much as possible to somebody without totally confusing them or communicating something erroneous about the data. So he's got a lot of really great guidelines that he uses, and he's got some fantastic books. You should Google them and grab the books if you haven't seen them before. But the goal is to provide useful visualizations immediately. So you should be able to sit down and in one screen kind of get a quick overview of somebody and see where are they at, what are their vitals doing, what meds have they taken, what's happened to them recently. Allow users to kind of recombine the data, because we can't predict how people are going to be able to cognitively best process what they're doing on a day-to-day basis. So they should be able to drive how they're consuming the data, and then really be able to tie that back to population-based metrics. I mean, everything we've talked about has been on the single patient, but now the governmental rules are changing where providers are going to be actually reimbursed based on how their entire population is doing as well. And not only as a fiscal thing, but you should be able to get feedback as a practitioner to say, hey, you're doing a good job, or you're doing really crappy. You should change, how you're doing something.
So like I said before, this is really what you see when you get into the EMR is this table. You can't really filter. With about 5 clicks, you can generate a graph of some of the lab values, and I've had physicians tell me when they get to that, they'll take me to a computer not always knowing, my computer background, and be like, I got to show you this really cool feature, and they'll show me a graph that isn't actually even appropriately scaled, but shows data from the last 3 years, but not spaced accurately. So, when you come in and we're actually looking at patients, would you like to see that, or would you rather be able to move this down into a simple graph which displays all of that same information, but a little bit more useful? So rather than actually seeing the table, be able to filter this by time, see a min and a max, the most recent, and the chart of where have these vitals or lab tests actually been, rather than trying to sift through the entire table of data, trying to find the difference between this and the non-claims page is almost impossible because there's so many results in there, where if we go from the visualization page to the other one, you can immediately see, just because the amount of data is so much less, when you compose this into a chart rather than a big long table of numbers that become rather meaningless to anybody that's actually practicing. Mm-hmm. So that's the last demo we have, and with that we can take any other questions.
One thing to mention, so I guess our point for giving this talk is not that we're the company that's going to solve all the problems. Basically, what we want to bring up is there are a lot of problems in healthcare. We want to get people excited about the data because the data are really neat. I mean, there's so much data out there that we haven't even scratched the surface on that can be sliced and diced and presented in a bazillion different ways on many different platforms with a whole bunch of different technology that's coming to bear. But we need people that are active in the tech community getting into that area. They've been in financial services and other places, but they're not there yet, and we need to really bolster that. And we wanted to show that, the tech is there. It's easy to use. There's all sorts of new things that we can bring to bear. We have one data set right now that's about 20 terabytes. It's got a whole bunch of MRI imaging data. It's all in Mongo and SQL, hybrid data store, the whole bit. You can slice it and dice it 2 ways from Tuesday. Process the data on a supercomputer. It's all in Python. I mean, it's there. It's just a matter of getting everybody kind of excited to play. And the neat side effect is you actually have really big impact on people's lives because you're helping them be healthy. So, yeah, with that, we'll take questions.
One of the comments I have about Mongo is I think you made, and one of the benefits, I don't know if you covered it, was that the schema system on a relational database versus document database is completely different. Mm-hmm. And it's this very scary process of moving, changing schema on a relational database. It could easily break the system. Mm-hmm. Whereas with a document database, if you make a change, it could literally just be written into the application, and you can just do it on a per document basis. And it's very low.
Yeah, and I didn't really explain that well, but yeah, that's what I was meaning when I was saying, we can dynamically change the type of data that's going into these databases, so you don't have to restructure your entire database schema plus your application plus your UI. You can make a simple change and have that automatically dropped in. Mm-hmm. Same for the reporting side. You can make those reports, very dynamic rather than very structured to your existing table schema.
And the nice thing is because, like you said, the schema is really baked in to the records, and if you lean heavily on URIs, the data are self-describing semantically, and then they can, be slowly changing interfaces over time, and the system can just accommodate that rather than freaking out and blowing up. They do currently.
Maybe I missed the first 10 minutes, maybe I already answered it, but can your data ideas or your plans be accomplished in a Hipaa world? Do you have to blow Hipaa up, or can we figure out how to work within the current structure of Hipaa?
So yeah, all of this actually fits in fine. So the Hipaa requirements they sound very scary. The big thing is encrypting any data that's identifiable, and then making sure that you have the correct permissions to share that data later on. Mm-hmm. And so part of this requires some of that consent to actually start being digitized. Right now all of the consents are paper and everything else. There's actually a big push nationally for the National Health Exchange, NWIN is the name of that, where they're actually working on figuring some of these out. I always get it confused with the green initiative because I think they're backwards. There's the big blue button versus the big green button for data interchange between these systems. And right now it just relies on the provider. The provider's supposed to get consent, and then they can click the button and get access to everything. And that technically is being allowed by HIPAA. So, the things that are happening now are falling in that framework with much less security than some of the things that we're potentially suggesting, where you can actually start to limit and secure that data. It requires a little bit more thought of how are these systems structured, but can fit perfectly in. Same with Mongo. The MongoDB doesn't offer tons of security baked into it, but if you're limiting that onto a single machine with the correct, boundary restrictions, you can encrypt the disk, and now you are HIPAA compliant. So.
And I think, a lot of the HIPAA regulations are less restrictive than some of the SEC regulations or like Sarbanes-Oxley. When all that came out, it was just like, totally unmanageable. And HIPAA really can kind of get boiled down to a handful of requirements that can be addressed. Mm-hmm. Yeah, absolutely.
I have some general question about trends and what your understanding of the hospital payers, providers, the entire system of how they understand, the problem and so forth. Is it your sense that, people who are buying the software and the users of this kind of understand the background like you presented here and how to really be thinking about how to adapt technology specifically for consumer, because that's what really matters. Because where this is really fun is when it's integrated into something I can pull up on my iPad at home and oversee what's going on across the board.
Yeah.
So, tough question. Just kind of a broad brush question, if you will. Like, do people in healthcare really get what's going on?
No.
Not at all.
Not even remotely. They know they want it. Like they
know there's a problem. They
Yeah.
don't know how to solve the problem, and the vendors will come in and be like, oh, you need to meet high-tech compliance for the High-Tech Act. So we have an EMR. It meets the 5 criteria for meaningful use. This will solve your problem. Well, it meets the criteria for the law. It doesn't necessarily solve the problem. So, a lot of people know that there's an issue, but I haven't seen really I can't think of a single hospital or clinic or practice where the doctors are like, oh, awesome, we're getting an EMR tomorrow.
Let's take the next step then. I mean, how as a community can we help solve this?
So I think.
Just general ideas.
Yeah, I mean, one is, trying to talk to your physician. I think you actually had a story about getting your personal health record from a doc when you went in to see him. Trying to engage them. Tell them it's something you want. Otherwise, a lot of time, they'll just assume that, hey, this is only something 1 or 2 of my patients need. So what's the advantage to moving towards that?
Yeah.
The other thing is, in interactions, if you're working on an IT project for a hospital, encourage them to try to innovate a little bit. It's really tough to do, especially with a lot of the people who are currently in those systems. But, encourage them to try something like Mongo or, even if they don't end up using it, just look at it. It can be HIPAA compliant. And try to explain those things to them.
Yeah, I think that's spot on. I mean, it's not the tech people at the health systems that are really the problem. It's the higher ups and the worry. And I've gotten a lot of feedback when I've sat on informatics committees. They're like, oh, you don't understand. We have a lot of data. I'm like, well, make me understand. How much data do you have? Oh, we make a terabyte a month. I'm like, okay, that's fine.
How many hits does your system get? Oh, we've got about 1,000 users. They hit it about 5,000 times a month. And these are their big numbers.
Yeah, I mean, it's like go to a big.com and then we'll talk about some data, It's just getting those people who are used to dealing with, well, we have 100 million users and we generate, a petabyte of data a year. Getting those people into healthcare in sort of a collaborative fashion, I think is going to be the key. And then having sort of the new generation of hospital management and administration starting to kind of turn over. And then also really getting together frameworks that work, that are manageable. I mean, there are a bunch of initiatives out there like open source. They came out of academia. They're all totally unmanageable and they don't work, and we've tried it. We've done a couple of projects with some of the departments over at the U, and we tried to use the open source things that have been built by, these big government grants, and they fall apart. And so we end up kind of rolling our own, and that's not great. I mean, it works better, but what we really need is some sort of like, what is it takes a community to raise or a village to raise a child, that sort of thing. I mean, we really got to get a heterogeneous design pattern, I guess, built up for this sector. Yeah, and when you look at the baby boomers, I mean, everybody throws out the $5 trillion number. You know, it's going to cost $5 trillion to manage healthcare for baby boomers. So, I mean, it's a disaster coming, and we have no way to do it. You know, and there aren't enough providers at any level to handle folks.
Fortunately, a 300 million installation is a small fraction of the 5 trillion.
Oh, that's true.
Not that big of a deal.
They're deep into existing investments in their infrastructures, and they're trying to make the switch, but it's, you know, the 1,000-pound gorilla trying to change course. You know, the big one we always see is Epic. That's a really common one, and you know, 2 nurses from Wisconsin took the VA system, skinned it, and now they're sitting on a pile of money and a pile of bugs. You know, and they're trying to figure out how to change course, and it's going to take time. But it seems like, you know, we've had so many other cool open source initiatives that have happened. Why can't healthcare benefit from something like that?
So it's nothing inherent with the open source stuff as a concept. It's that, you know, the open source systems that are out there are the ones that are written in mumps.
Yeah.
Or there's a lot of ones that are based on,
Yeah.
yep. Or they're based on Java and MySQL, which, you know, for a small implementation, probably not a big deal. But without a ton of configuration, you try scaling up that Java and MySQL install up to, you know, 1 million patients, and you start to have, you know, you can get it to work, but there's a reason Facebook had to rewrite, you know, all of their internal PHP and MySQL stuff, and that hasn't been done, you know, completely publicly. So they work on small scale, but once you start revving up from one department at some academic institution, writing it and using it to trying to scale this out to like the national health system in the UK, it just doesn't really work.
Yeah. And I was just going to say there's no community there either yet, you know. Every time we've found small partners here and there, but when we've tried to work with some of the partners at the big health systems, we've just had trouble with either red tape or know-how issues.
Yeah, I mean, the big ones are basically these small groups. I mean, there are a couple of them. They just aren't big. You know, OpenEHR is one, which is based off of Vista, so it's in mumps. There's Open Clinica, I think, or there's a set of them, but pretty much every one of them is the VA system that they copied and have rewritten a little bit.
Yeah. Exactly.
You can't really do that with mumps, unfortunately. It's not very modular.
Exactly.
It tightly couples basically everything.
Yeah.
So you can't really split it out very well.
Well, and I mean, and that goes exactly to the heart of the point. It's like, why aren't we building composable systems? You know, I mean, it's been done everywhere else. You know, like financial services, you can pull in a mutual fund provider, and you can pull in, you know, like a derivatives provider, recombine them, do whatever you want with the data, and have some new swanky tool. You know. Why can't we do that in healthcare? And the risk is still there, too. You know, I mean, brokers and banks, we work with a bunch of big brokers, and they have all sorts of, you know, Fidelity, how many trillion in assets, you know, so the security's there. You just need a well-defined platform to deal with it, you know.
I think we're just getting towards the end. We can stick around, so if anybody has questions or grab us out in the hall afterwards. But thank you for coming. If you have any questions, just let us know.